Vernier calipers. Click on the links provided. Construction. Vernier calipers is used to measure the length, thickness, diameter and depth of an object and to measure the internal and external diameters of a hollow cylinder. Vernier calipers is also known as slide calipers. Pierre Vernier devised a method by which length correct up to 0.1 mm can be measured. The two scales that you see on the Vernier calipers are the main scale and the vernier scale. The main scale is a long, thin steel strip with a jaw J1 at one end and is graduated in millimeter. The vernier scale is a graduated movable steel strip with a jaw J2 that can slide over the main scale. Generally, the vernier scale has 10 divisions marked on it. The vernier scale can be fixed at any position on the main scale with the help of a screw. The jaws J1 and J2 are parallel and projected on either side of the main scale. The lower jaws are called the outside jaws. They are generally used to measure the length or thickness of a given rod and diameter of a sphere or a cylinder. The upper jaws are inside jaws and are used to measure the internal diameter of a hollow cylinder or pipe. There is a thin long strip T attached to the vernier strip at the back of the main scale. This is used to measure the internal depth of the cylinders or hollow tubes. The object to be measured is placed in between the lower and outside jaws. Using the vernier calipers. Whenever we use vernier calipers, we have to first find out the least count and zero error of the instrument. Least count of a vernier scale. Least count of an instrument is the smallest measurement that can be recorded accurately with it. To know the smallest measurement, we must first find out the number of divisions on the vernier scale and the value of one main scale division. Let us now calculate the least count of the vernier calipers that is shown here. Number of divisions on the vernier scale is equal to 10. Value of one main scale division is equal to 1 millimeter. Therefore, the least count is equal to value of one main scale division by total number of divisions on the vernier. Least count is equal to 1 millimeter by 10. That is equal to 0.1 millimeter. That is equal to 0.01 centimeter. Zero error in vernier calipers. It is found that at times when the movable jaw is brought in contact with the fixed jaw, the zero of the main scale does not coincide with the zero reading of the vernier scale. This is a mechanical error and is referred to as the zero error of the vernier calipers. Depending on the position of the zero of the vernier scale, the zero error can be of two types, namely positive zero error and negative zero error. Shown here are three vernier calipers A, B and C. In the vernier calipers A, the zero of the vernier scale and that of the main scale coincide. That is, the vernier calipers A is free of zero error. In the vernier calipers B, the zero of the vernier scale is to the right of the zero of the main scale. This vernier calipers is having a positive zero error. Let us now find out the positive zero error. Note the vernier scale division that coincides with any division of the main scale. Now to get zero error, multiply the coinciding vernier scale division by the least count of the vernier. the vernier caliper C is having a negative zero error, as the zero mark of the vernier scale is to the left of the zero of the main scale. To find the zero error, first note the division of the vernier scale that coincides with any division on the main scale. Subtract the coinciding division from the number of divisions on the vernier scale. Multiply the difference by the least count and assign a negative sign to it. After finding out the least count and zero error of the vernier calipers, calculate the observed reading using the formula. Observed reading is equal to main scale reading plus coinciding vernier scale divisions into least count. True reading is equal to observed reading minus plus or minus zero error. Applications of vernier calipers. Vernier calipers is used to make more accurate measurements of dimensions of objects. In the engineering industries, precise length, breadth, thickness, outer and inner radii of hollow objects are calculated using vernier calipers. Vernier calipers is used to measure length of small objects like components of a machine, breadth of a cantilever beam used in building structures, thickness or gauge of various steel sheets, outer diameter of the spherical valves used in automobiles, inner diameter of a hollow cylinder. Determination of the length of a rod. To measure the length of the given rod with the help of a vernier calipers, the following procedure is adopted. First, find the least count of the vernier calipers. Now check whether the vernier calipers has zero error or not. Fix the object to be measured between the jaws J1 and J2. Note the main scale reading. Note the vernier scale division which coincides with any of the divisions of the main scale. Record the readings in the observation table. Repeat the experiment by adjusting the position of the jaws of the vernier calipers at different positions of the rod. Length of the rod is equal to 4.58 centimeters.